Hey guys, and welcome back to another video. In this video, we'll be talking about composition and inverse functions. Alright, so let's get right into it. So to begin with, let's start with composition functions. So for composition functions, there's 5 main operations that you need to know. So you have f plus g of x, f minus g of x, f times g of x, f over g of x, and then f of g of x. Okay, so for the first three, the domain is just the intersection of the domains. So it's just like the intersection of the domains of f and g. So that's for the first three, just the intersection. Right? For this one, f over g of x, it's also the intersection, but you also have to exclude any values that make g of x equal to 0, because this is basically saying f of x over g of x, and that means g of x is in the denominator. So if g of x equals 0, then it's undefined. So it's the intersection and g of x cannot equal 0. Okay, and then for this one, the domain is a little bit more complicated, but we'll get to that later on in the video. Okay, so what do each of these mean? So f plus g of x, this is simply just saying f of x plus g of x. So if you have two functions f of x and g of x, the operation f plus g of x is simply just adding the functions together. So that means that this one is just subtracting the functions. This is f of x minus g of x. This is multiplying them. So f of x times g of x. This is dividing them. So those are like the four basic ones. And then this one is saying f of g of x. So what I mean by that is like this is saying f of g of x. So essentially you're giving the function g of x as input into the function f, and then you have to simplify from there. Okay? So let's do some examples for this. So let's say I gave you two functions, f of x equals square root of x minus 1, and g of x equals square root 4 minus x, right? And I want you to find f plus g of x, f minus g of x, f g of x, f over g of x, and f of g of x. Okay, so pause the video and see if you can figure out these solutions. All right, so I'm assuming that you had a go at it. So let's work through these one by one. So for the first one, f plus g of x, this is simply just saying f of x plus g of x. So it's just the first function, which is square root of x minus 1, f of x plus g of x, which is the square root of 4 minus x. And you can't simplify this any further. So this is just the function. And then the domain for this one would just be the intersection of the domains of f of x and g of x. So the domain of f of x, I'll write it up here, is, so it's a square root, right? So you can't have any negative values. So it's really just x minus 1 has to be greater than 0. So the domain would be from, let's see, 1 included to infinity. All right. And then for this one, the domain would be from negative infinity to 4 included. So basically, it's just like the stuff under the square root can't equal 0 or can't be less than 0. Okay? So then if we take the intersection of these two domains, you get from 1 to 4. Right? Because that's what they have in common. That's what the intersection is. Because this one's going from 1 to infinity. So like if we draw like a number line or something, and let's say this is 1. So this one is like 1 included to infinity. So it's like going that way. It's all of that. And then for this one, it's negative infinity to 4. So like if 4 is like right here. then it's all of this stuff right here, right? So the only stuff they have in common is between 1 and 4. All right, let's do the next one. So now we have f minus g of x. So that's just f of x, which is the square root of x minus 1. And now it's minus g of x, which is 4 minus x. And the domain is the same. And then f times g of x. So now you have f of x, which is root x minus 1. And then times g of x, which is root 4 minus x. And this one you can simplify further. So you'd get, let's see, put both of them under the root radical, right? And then if you were to like distribute this out, you would get the square root of negative x squared plus 5x minus 4. So that is the final like simplified answer. And the domain for this one is also just the same. It's just 1 to 4. Because remember, for f plus g, f minus g, and fg, the domain is all just the intersection. And so once you find the intersection once, it's going to be the same for all three of those. For this one, however, remember the domain is the intersection, but you also have to exclude any values that make g of x 0. So for this one, it's f of x over g of x, so it's the square root of x minus 1 over square root of 4 minus x. And you have a radical in the denominator, so you want to rationalize this. So multiply top and bottom by root 4 minus x. And then once you rationalize it, you should get negative x squared plus 5x minus 4 over 4 minus x. Okay, so when is the denominator equal to 0 here? It's equal to 0 when x is equal to 4. So like before, we included 4, so now the only difference is that we don't include 4. So it's 1 included to 4 not included, whereas before it was 1 included to 4 included. All right, cool. And then finally, f of g of x. So this is just saying like f of g of x, like this. And order matters, right? So if this was like g of f of x, this would be a completely different thing. This is g of f of x. So the order that this is listed matters. Like over here, for like this one and like this one, the order doesn't matter. But for composition of functions, like for this one, order 100% matters. Okay, but this is just saying you take f of x, which is the square root of x minus 1, and you're going to replace x with g of x. So you're essentially taking this whole thing, the square root of 4 minus x, and putting that in for x right here. So you get the square root. I'm going to open a big square root, and then instead of x, you're putting in g of x. You're putting in this whole thing, the square root of 4 minus x. And then you still have that minus 1 outside. So it would just be that. It definitely looks a little messy, but it is what it is, right? And then, yeah, that's that. And then for the domain of this, so this is where it gets a little bit tricky. So basically, when you take compositions of functions, right, the domain of f of g of x is just the domain of g of x with whatever restrictions f of x has. What I mean by that is if we had some set right here, and we call this the domain of g, right? So let's say this is the domain of g. And then it goes to this other set range of g, right? So this is the range of g. So what the function g of x does is it takes some element from the domain of g and it maps it to some element in the range of g. So this is what the function g of x does. But for the composition of functions, whatever value we get right here is what we're inputting into x. So essentially the range of g is also the domain of f in this case. So this set is also the domain of f. And so then we go from the domain of f to the range of f. And we're basically taking this point and going to a different point right here. And this is what f of x does. All right. So in order to find the domain of this whole thing, we must first find the domain of g of x, which we found was from negative infinity to 4 included. And then once we find that, we have to find the range of g. So the range is from 0 to infinity, right? Because the least possible value this could be is 0. So I'm going to write this right here. The range of g, in our case, is from 0 included, and then it just kind of blows up to infinity. So from 0 to infinity. All right? And then the range of g is the domain of f. So now we have to see, is this okay for us to put into f? And the answer is no, because the domain of f is this, but the range of g is this. So we have to restrict the domain of g such that the range of g becomes the domain of f. So so basically we have to exclude 0. So what value of x makes g of x equal to 0? That's if x is equal to 4. So if we restrict the domain from 4 to, let's say, 3, then this will work, because now the new range after this modification to the domain is from 1 included to infinity, right? Because now the least possible value is 4 minus 3 square root of that is 1, and the maximum possible value is still infinity. So the domain of this whole thing is just this domain. So hopefully that makes sense. I will go more deeper into this later on in the video. I'll definitely do more examples. And matter of fact, let's do some more examples right now. So, let's say now we have a function f of x is equal to x squared plus 1, and g of x is equal to x minus 3. Okay? So now you want to find a f of g of x and b g of f of x. All right. So again, pause the video and see if you can figure these out on your own. All right. Now let's work through them together. So for the first one, f of g of x, this is just saying f of g of x. So you're putting g of x as input into f of x. So wherever you see x and f of x, you're going to replace it with a g of x. So here we have x squared, but x is now g of x, which is x minus 3. So we have x minus 3 squared, and then plus the 1. And if we to expand this out, we would get x squared minus 6x plus 10. All right? And then for g of f of x, so now this is where the order matters, right? Because this is g of f of x. So now we're taking this function and putting it into x in here. So instead of x, we're going to replace that with x squared plus 1, and then minus 3. So then overall, this becomes x squared minus 2. So notice how the order matters, because here we got two completely different functions. Okay. All right. Let's do, so this would be example 2. Let's do another example. So let's say we have f of x is equal to 1 over x minus 1, g of x is equal to 1 over x. All right, so again, pause the video and see if you can figure out f of g of x and g of f of x. All right, so f of g of x, that's just f of g of x like this. So that's just putting g of x into here. So you should get 1 over x, replacing with 1 over x, so 1 over x minus 1. And then simplifying this, you should get, let's see, x over 1 minus x. Right, because if you just multiply this whole thing, top and bottom, by x, on the top you get x, on the bottom you get 1 minus x. Okay? And then g of f of x, this is equal to, so now you're putting this into here, so you get 1 over x minus 1, so then 1 over 1 over 1 over, that just becomes x minus 1, right? All right, cool. So now let's talk about the domains of these functions more in depth. Okay. So let's say, example 4. So let's say we have some function f of x is equal to 1 over x minus 2. And g of x is equal to the square root of x plus 2. And we want to find what is the domain of f of g of x. Right. So I'm going to draw that picture again. So we have this set. This is the domain of g. Okay. And then we have another set. This is the range of g. So if we take some element from the domain of g and we want to map it to some another element in the range of g, this is exactly what g of x does, right? So g of x takes an element from the domain of g and it maps it to the range of g. Okay. And then for compositions of functions, f of g of x. The domain of f is what you're inputting into f. So f of g of x is the same thing as f of g of x, like that. So g of x is just the range of g. So what you're inputting into f is whatever you get out of g. So this point is in the range of g, so this would also be the domain of f, because this is what you're going to be mapping to the range of f. So you're going to take this point and map it to some point in the range, and this is what f of x does. Okay? Because I just want to make sure that this is really clear, because this is fundamentally how we determine the domain. It's just using this idea right here. Because the domain, because like the range of g and the domain of f have to match. That's like the key realization in order to figure out what the domain of these functions are. So let's just start with finding the domain of g. Domain of g, x plus 3 has to be greater than or equal to 0, so it's just from negative 3 to infinity. Right? And then the range of g is what all possible values that are outputted, and that's just going from 0 to infinity, 0 included to infinity. Okay? And now let's look at the domain of f. So the domain of f, x minus 2 just can't be 0. So that means that x can't be 2. So you can just, from negative infinity to 2 not included, union 2 to infinity. Right? That's the domain of f. So we want the range of g and the domain of f to like be the same in order for us to be able to find the domain of g, or the thing. So first of all, the range of g is all non-negative numbers, right? So it has to be greater than or equal to 0. So we can automatically just get rid of this negative infinity to 2 part, or like negative infinity to like 0 part. So then this just becomes, if we kind of get rid of this part, you're just left with 0 to infinity, but x can still not equal 2. Okay. All right, good. So now our domains and range look pretty much the same, right? They're both 0 included to infinity, but the only difference is now that for f, it's just that x can equal 2. So that means that g of x can equal 2, because if x can't equal 2 for the x and f of x, that means that g of x, like the range of g, can equal 2. So what we're going to do is we're going to set g of x cannot equal 2, right? Because g of x is the range of g and x is the domain of f. So if x can equal 2, then the range of g, which is g of x, cannot equal 2 either. Okay? And now we can just solve this equation. So g of x is this. It can equal 2. So square both sides. X plus 3 can't equal 4. And so that means that x can't equal 1. So that is the restriction that we have to make to the domain of g. Right? So the domain of g originally was from -3 included to infinity. But in order for this to satisfy f of x, x also can't equal 1. So the new domain of g would be, let's see, I'll write it like right down here. So the domain of the whole thing is still -3 included to 1 not included, union 1 not included to infinity. So this is the new range or domain. All right. All right, good. So essentially, the key thing is that like we found domain of f and we found a restriction on the domain of f, which is x cannot equal 2. And if the domain of f has a restriction, that means that the range of g must have the same restriction, since range of g and the domain of f are the same for the compositions. For compositions, the range of g and the domain of f are the same. So that means that g of x can equal 2, and then we solved that equation, and we got that x can equal 1 in the range or in the domain of g. And so then we applied that restriction, and we got the domain of the whole composition. Okay, good. All right, so now let's change our focus over to inverse functions. All right, so let's go over to inverse functions now. So an inverse function is basically like, I'm going to draw this again. So let's say we have two functions, f of x, and I'll use h of x just like for a change of scenery. So let's say we have f of x and h of x. So let's say this is the domain of f, and this is the range of f. Like we've already seen that to go from the domain of f to the range of f, that's what f of x does. What an inverse function though does is it takes the element from the range of f and it maps it back to f of x. So it takes this element and it maps it back to this. So that's what h of x does. And more commonly, we would actually call this f inverse. So I'm just going to change this to f inverse. So that's what the inverse function does. It basically takes an element from the range of g and it maps it back to the domain of f. Okay? So the only way this is possible is if the function is 1 to 1. So what does it mean for a function to be 1 to 1? So 1 to 1. So basically it means that if you have two input values, x1 and x2, that are not the same, then this means that the output values of those two things also can't be the same. Right? So if you have like, for example, if you put in 2 into the equation and you put in 3 to the equation, you're not allowed to get the same output value. All right? Because like, for example, if we had like a parabola, like I'm just gonna draw a mini sketch right here. If we had like a parabola or something, and let's say like we inputted like 1 and -1, like let's say this is like f of x equals x squared, right? And we input two different x values, so -1 and 1 into this, you would get the same y value out, right? Both times if you input -1 or 1 into f of x, f of both of these is equal to 1. So that's why f of x equals x squared by itself is not 1 to 1. However, you can restrict the domain, but I'm not going to really get into that in this video. But like you would be able to, like if you just like restrict the domain from like, for example, 0 to infinity, then like you only have like this half of the graph, and then that would be 1 to 1, right? Anyway, but for a function to have an inverse, it has to be 1 to 1. Okay, so yeah, that's that. And then solving for inverse functions, the first step is you're gonna have some function f of x, and you're gonna like change the variable equal to y, right? And then you're gonna switch x and y. So like switch x and y. And then third step, solve for y, right? So this is best explained doing some examples. Let's just get into examples quickly. So this is like example 5, I believe. So if we have some function f of x and it's equal to the square root of x plus 2, and we want to find f inverse of x. So the first thing we have to do is determine, is f of x 1 to 1? The answer is yes. It is 1 to 1, because for every input value that you give this, you're only going to get a unique output value. Okay? So yeah, it is 1 to 1. And so then what you have to do is basically take f of x and replace it with y. So you just change this to y equals x plus 2. And then switch input output. So like switch x and y. So x is equal to the square root of y plus 2. And then from here solve for y. So you square both sides, subtract 2. So this is our inverse function, x squared minus 2. So f inverse of x is equal to x squared minus 2. And in terms of finding the domains of these, so remember how I said that the inverse function takes an element from the range and maps it to the domain? So that means that the domain of the inverse function is just the range of the original function. So if we just find the range of f of x, it's from, let's see, 0 included to infinity, right? That's the range of f, is 0 included to infinity. So that's just the same thing as the domain of this. So then the domain of f inverse is just the range of that, so it's just the same. And similarly, the domain of f of x is just the range of f inverse. Okay? Okay, let's do one more. Or let's do a couple more. So let's say I gave you g of x equals absolute value of x, and I want you to find g inverse. So the first thing we have to ask ourselves is g of x equals square absolute value of x, is that 1 to 1? It's not, right? Because if we're to look at the graph of absolute value, it looks like that. It's a V-shaped graph. And so we can automatically see that if we had like this, let's say this is like x1 and this is like x2, two different x values, but they both map to the same y value, right? It's the same y value. So not 1 to 1. So just because it's not 1 to 1, no inverse. All right, so now let's move on to example 7. So let's say I gave you some function f of x is equal to 2 over x plus 3, and I want you to find f inverse of x for this function. Okay, so the first thing we have to see is f of x 1 to 1? And yeah, it is, right? Because for every input value, there's exactly one output value for this function. So it is 1 to 1. So that means that the inverse function does exist for f, so we can find it. So first thing is just replace f of x with y, so y is equal to 2 over x plus 3. And then switch x and y, so x is equal to 2 over y plus 3, and then solve for y. You get y is equal to, let's see, 2 over x minus 3. And it's always good practice to like use inverse function notation when you're dealing with these functions. So f of inverse of x is equal to 2 over x minus 3. Okay, and then the domain of this is just the range of this. So range of this one would just be from negative infinity to 0 union 0 to infinity, right? So that's the range of f. And it's because this can never equal 0, right? Because like if you were to graph this, it will look something like this, right? So it never actually equals 0. And so then, but the range of this is just the domain of this. So domain of f inverse is just negative infinity to 0 union 0 to infinity. Okay? All right. But yeah, that's pretty much it for composition and inverse functions. If you enjoyed this video and you found it helpful, please make sure to subscribe so you don't miss any future videos. And I'll see you guys in the next video.